Robert now. And I hope you stick around for the presentations. Robert's house is gorgeous. I've gotten to be in it. Robert has a longer introduction than perhaps I have time to give, but the house itself is going to be amazing for you to see. Robert has a long background in green building. He is one of the people that you'll see at conferences, going to all the building science sessions. He built this house himself, and he's a consultant in the area on green building generally. Went to the Wharton School of Business. He, as a professional, works with a wide variety of large corporations to help them with leadership training. And hopefully he'll illustrate how he's taken personal leadership here. So with that, Robert, you're unmuted. Can you say hello?
Yes. Sean, can you hear me?
We can hear you. You're coming through perfect.
All right, fantastic. Thanks
take it away. So you just say next slide and Amanda will work with you.
Okay, Amanda, next slide, please. It's a pleasure being with all of you. Thank you, Sean, for the kind introduction, and Lee Link, congratulations on the great work that you've done. It was a pleasure viewing your presentation. So what I'm going to talk about today is a house, a net zero energy, zero carbon retrofit of our existing house that we actually completed 6 years ago, which is hard to believe. But we want to talk about today. What we want to talk about today is how we did it 6 years ago and what we've learned since. We actually live in that house. We occupy that house. Sean has been there, has stayed over, and knows the intimate details of how it works. But we want to discuss that a bit. What does work? What are the metrics behind that? What is working and what's not working? There's some things that we learned in the process that we'd like to share. And we've been learning in the process of actually living in the house, which I think is a unique perspective, from the design to the build to the occupying of the house. There's some things we learned that we'd like to share. We'd like to talk a little bit about the why and the how behind the decisions. We also have done a TED Talk, which you can easily find by putting my name in TEDx. So we don't want to duplicate a lot of that because you obviously can find that elsewhere. And this format has a specific purpose, and we want to stick to that purpose. And then I love the fact that questions just keep railing up, and I want to make sure that we're responding to those questions. And Sean, if you could help me by just scanning the questions as I go through my presentation, if it makes sense to jump in with a question as we're going through it, I'm very happy to do it as a dialogue as opposed to just a monologue. Next slide, please. I mentioned the TEDx, easily found at our Green Idea House. You can go to the next slide, please. I wanted to start with gratitude because this project actually started about 10 years ago, and it started with you could see in the TED Talk the whole backstory. But at the point we reached frustration, knowing that this was all possible, but not actually seeing it done. I reached out to some friends of mine, and we started taking classes, and some of the first people we bumped into were Rick Chitwood and an incredible team of people who put on a 9-day class. And then I took classes from Ann Edminster and Brad, and just the number of people that I see here gives me great gratitude, because I think we have to remember that we're all in this community together, and to do something that is really an act of social and political activism, the things that we're all up to, really requires a lot of bravery and a lot of friendship. And so I really wanted to start with the gratitude around the friendship that so many people have showed me and shared with me their expertise that allowed us to do this project. Next slide, please. That extended into our groundbreaking, where literally hundreds of people, and we had over 5,000 people through the project as we were in development and in construction. Next slide, please. And then we also partnered with about 70 public and private agencies that were interested in the idea, and they wanted to lay a bet down that we could actually do something that at the time had never been done. That is to affordably do a retrofit that was net zero energy and zero carbon, that was made with standard construction materials and off-the-shelf technologies. At that point that we were contemplating that, we just hadn't seen it. Next slide, please. So through the process, we shared the idea. You can see Wes Harding there, who attended some of the classes with me and got involved in the building of the project. Next slide, please. We did all kinds of blower door demonstrations and really helping people understand what energy efficiency was at that time. Next slide, please. There's Ed Begley Jr. At the groundbreaking. We had been to a lot of groundbreakings, or I'm sorry, the ribbon cutting, and we had been to a lot of ribbon cuttings where people stood in front of a building and said, this is what we think this building will do. We actually waited a year until we had real data as to what the building was doing. And even if it didn't work, we wanted to do that to show what was happening and why things were working and not working from real science, real data background. Next slide, please. And we also then wanted to share. And so, you know, I spent thousands of pro bono hours just dedicating myself to share what we've learned. Next slide, please. And we were really honored to receive the Green Leadership Award for Los Angeles County and the Build It Green Contractor of the Year Award and a number of other awards that you know, I just wanted to say really don't belong to me, but belong to the broader community that helped bring this forward. Next slide, please. So the project was meant to hit very specific metrics, and I'm a business person by trade. Again, I'm trained as an economist, not a building science person. And so these metrics were really important to me, and hitting $200 a square foot. I know if we were 10 miles east of our current location, we could have done it less expensively, but that's what it came out to. And that's what we were targeting, figuring that most people can understand how that's a reasonable number. In my mind, as a economist, you know, I went to all these building classes, but it really came down to these green building classes. But if you use less material, you create less waste, you do it with less embodied energy, you do it with less toxicity, less water, it should actually be less expensive and more resilient at the same time. And that's the nexus that we were trying to put together. Next slide, please. And my wife always says to me, don't talk anymore. You need to show pictures because people need to see it. So this first slide shows what the building actually looks like. And the design for it, we'll talk about it in a little bit, but it's very, very specific to the site and what was there before. We reused the old foundation that was there, you know, basically for, again, embodied energy reasons, but also because it saved us $50,000 in reporting a foundation. And so that was kind of the mindset in between all these decisions. We had to make sure it worked out from an economic as well as an environmental perspective. Next slide, please. Here you can see we built a thermal chimney in the stairwell. Very, you know, we tried to use ancient principles. People knew stuff. You know, if you go to the Middle East, you understand that almost every house has some form of a thermal chimney for a very good reason. And that's how we do air circulation in the house. Next slide, please. You can also see the daylighting. Every single room in the house, if the sun is out, does not have to have a light turned on in it. Next slide, please. And you can see some of the solar panels on the roof and the roof design. The back part of the house is actually reused from the 1959 post and beam building that was there. So again, we tried to reuse every stick and stone. On the lower right-hand side, you can see the head of the 1,400-gallon rainwater tank that captures all the rainwater from the 1,500 square foot roof. Next slide, please. And, you know, this is the real proof that we were looking for. After a year's time, what is the building actually doing? And if you're not familiar with the Southern California Edison bill, every one of those bills is a month that tells you if it's above the line that you're using more energy than you produce. And if it's below the line, you're producing more energy than you use. And as you can see, it's very clear to see that we knocked it out of the park. The engineers couldn't believe how well it actually worked. We modeled it up and we thought we were just going to skinny by because some people were doing all electric, attempting to do let me say this right. Some people were attempting to do the solar to cover their electricity, but not their gas. They were still using an incredible amount of gas. We wanted to make it zero carbon for a number of reasons having to do with fracking and, fossil fuels and all the rest of the issues related to that. So when the engineers, thought about what we were doing, they thought we were just going to squeak by. Next slide, please. But as you can see, we actually, from a time of use standpoint, over-generated by $1,399 and over-generated by 2.7 megawatt hours. So an incredible amount of energy, and that's with one electric car at the time. Next slide, please. This is actually our current, the most recent electricity bill. And as you can see, it has changed in profile because we bought a second electric car, and we changed out one of the heat pump hot water heaters, which I'll describe in a little bit, which actually changed the profile because the heating loads, as you can see from December, January, and February, were the big loads in the house, despite the fact that we live in Southern California. Next slide, please. And here you can see the energy charge to date. This is the latest bill, is on a time of use basis, a negative 922.71, and my cumulative is 17 kilowatts. So it's almost perfect for a 6.2 kilowatt array to power a 2,100 square foot house and 2 cars. Obviously, there's a variability to how much we drive and other things like that, but the system, the overall system of how we designed and operate the house is working very, very well. And quite frankly, it's a giant leap forward in lifestyle. We're not giving up anything. There's no sacrifice here. Actually, things are working better from a health, comfort, and safety standpoint. Next slide, please. So we've talked a lot about electricity. Let's talk about the carbon. Next slide, please. We did something at the time that was seen as really radical, and it's one of the reasons why I really appreciate Sean so much. Is he is passionate about this subject and really gets it, and again is a warrior in the space. But we capped off the gas line. It actually took 3 or 4 calls to the gas company because they didn't believe that we actually wanted to cap off the gas line. And as you heard from Sean, it's hard to get gas installed. There's a long lag time. So we finally got it capped off. They put a lockbox on it, and we were just happy to be done with it. Next slide, please. For some of the reasons we described earlier, but as I worked with Sean, he really dug into what the danger in an earthquake zone. I mean, it occurred to me that it is very dangerous to pull a gas line into a building in an earthquake zone, but he actually brought up the statistics where up to 50% of post-earthquake fires are caused from the gas line being pulled into the property. Next slide, please. And we know what that looks like from the Loma Prieta earthquake. Next slide, please. And the Northridge earthquake. It's very clear what actually happened. 54 of the 110 fires were caused by having a gas line in the house. So not having a gas line in the house makes the resiliency of the property that much better. Next slide, please. So how do we get out of gas? At the time, heat pump hot water heaters were a novelty. We actually got some of the first ones from GE off the production line, and we used 2 of them. As you can see, there's 2 tanks on the left and 1 tank on, 2 tanks on the right and 1 tank on the left of the picture you're looking at. The 2 tanks on the left, we passively heat the garage. That is, there are windows in the garage door that face southwest, and with the overhang on our house allows there to be passive heating in the garage, which that steel tank that you see on the right-hand side is the old gas-fired water tank that was hot water tank that was in there, and we use that to bring the water up from 55 degrees to nominally 70 degrees just by the ambient temperature in that garage. Then we push it into the heat pump hot water heater for domestic hot water use. So that's a standalone system. Those 2 tanks work together along with one other piece of equipment that we installed, which was a drain water heat recovery system, which I'll show a picture of in a minute. The tank all the way on the left is for the heating system. GE does not recommend you use it this way, but we really don't need air conditioning. We're lucky enough not to need air conditioning. And so we tried to do this, again, as affordably as possible. And so we basically do baseboard radiant heating radiators in a manifold setup that turns on switches and thermostats in each room. But it's basically powered off of that. It was powered off of that 50-gallon heat pump hot water heater, and it worked just fine. The difficulty was that it was a little undersized, and so the 4,500 watt resistance heaters would pop on, and you could see the profiles that the electricity spiked as a result of that. We recently purchased, because GE was switching their lines and they sold them to Bradford White, and so we found a clearance 80-gallon tank for $1,300, and we swapped it out, and so that's what you saw in terms of the reduction of wintertime load. It was significant if those resistance heaters don't need to come on. The other benefit of this whole setup is that I'm storing drinking water. Again, in an earthquake zone, this is a critical thing. Most of the houses that we see go up are tankless hot water heater, gas-fired tankless hot water heaters, which means they have about 2 ounces of water in them. Not a smart thing to do in an earthquake zone. We know it's coming. We know what happens. The water pipes break, and it's going to be a health problem, health issue as we go forward. Next slide, please. So this is Gary Klein. A lot of you probably know Gary Klein, great friend of mine, great thinker in the space, and helped quite a bit with the water issues and some of the thermal issues in the house. And this is what's called a drain water heat recovery system, and it basically takes the water that's coming down, a vertical pipe, and we also have a horizontal one as well, and basically heats that water up. So as it moves to the shower input on the cold side, you don't have to use as much hot water. So it's been very effective in making sure that we don't have to turn on the resistance heat in the heat pump hot water heaters. Next slide, please. This is another friend of ours, Jim Creech, who came over, and he was commissioned by Edison and the other people who wanted to make sure this building worked. And the blower door test that he performed to make sure that this was actually working, I was upstairs, I was shutting windows and taping off some open receptacles, and he yelled up to me, "You can stop doing that now." And I said, "What do you mean?" He said, "We've never seen blower door tests like this." And the envelope that we created is really simple. It's 2x4 advanced framing. But before we put the insulation in, we got a smoke machine and a blower door. And Wes Harding was helping with this. He's a fellow musician, and he had a theatrical smoke machine. We pumped smoke into the building and then turned the blower door on so it pressurized the building. And then we just simply walked around the building and looked for places where the framer might have left a hole. And it was amazing to see stuff that you would have never caught. And as a result of that, we could create a very, very tight seal on the building. Next slide, please. Other people ask a lot, you cut off the gas, but I treasure my gas range. And I know chefs, friends of ours, who have a wool stove, and they moved it into the garage of this house that they bought. They were going to renovate their kitchen. And the fact is that there was an induction cooktop on their, in their kitchen, and they never used the wool stove in their garage. Basically, they realized how efficient and how healthy it is. The formaldehyde, the nitrogen oxide, and the carbon monoxide that are present when you have gas in the house, as Sean will tell you, are very dangerous to your health. Next slide, please. So what really works is passive solar. Next slide, please. We modeled the house with Google SketchUp long before we went into construction, and we really understood, as a result of the shading properties, that we could heat and cool the building significantly with just a 5-foot overhang. And I still don't see this done much enough. Let's put it that way. Where I think we should start with the premise that the building should basically heat and cool itself as much as possible, and then work, with the mechanical systems. And Lee Ling was talking about that earlier. But this concept actually allowed us to put less expensive windows in, because they shaded themselves and do other things that made the whole of the building less expensive. Next slide, please. Thermal chimney, as we talked about before, ancient concept. There are windows at the top of this this opening, and it naturally draws in hot air. It goes to the top, and cool air drops to the bottom. Even in the wintertime, we keep it open, not fully, but it allows circulation of air throughout the house. Next slide, please. We talked about daylighting. Again, no lights need to be on in the house. At the time, LEDs were just coming in, and they were too expensive, so we had to use compact fluorescents. And I was so happy. I was telling Sean, I found LEDs for 99 cents a piece. It's amazing how inexpensive what was very expensive 5 years ago, 6 years ago. Things are turning significantly. Next slide, please. In terms of time of use, this is how our building works in the middle of the winter. This is when we first started up, 2013. As you can see, we charge the car, at midnight, and then it goes down. The heating system comes on at 4 in the morning. We want to preheat and allow plenty of time, as sort of a slow buildup on the heating system. And then, we're cooking breakfast and we're doing that stuff, and then the sun comes out, and then, we go negative when the sun comes out, and then we're doing cooking and other things at the end of the day. But basically, that's the time of use profile for the house. Next slide, please. So what we found works. Number one, we talked about earlier, building community around all these kinds of things. The sharing of knowledge and information is so important. So I applaud Sean and everybody else, Pierre, who set up the decarbonization group, and all the other people doing the wonderful work that you're doing to really be social and political activists and bridge builders to make this all happen. The passive solar, the daylighting, the thermal chimney, all that's been working really well. The air sealing that we did really makes a difference. The heat pumps, the drain water heat exchangers, all have been, as I mentioned, especially once we swapped out to the 80-gallon tank. Really happy to know in an emergency that we are all electric. And we continue to monitor these things. And our electric cars have been just fantastic. Next slide, please. Here I wanted to share with you some of the oops, what it is that we could have done better. I wanted to get the solar on as quickly as possible. And I wasn't metering because I was worrying about framing and 10,000 other things. And the fact is that the half of the solar array wasn't operating for 3 months at the inception when they turned it on. Next slide, please. And then we also had a problem when a transformer blew, and it blew out half of my my inverters. And that was an expensive mistake because Edison doesn't reimburse you for stuff that they blow up on your property, because they have a reciprocal agreement that says if you blow up something on their property, you're not responsible. It's a little unfortunate because the likelihood of me blowing up something on Edison's property is next to nil. But nonetheless, the surge that came through the house started fires on my street and other things, and it blew out half of those inverters. And so it was an expensive fix. The solution is simple, though. We're putting more and more complicated stuff into houses, and we need to have a whole house surge protector installed. And so we have installed one since. Next slide, please. And so what if could have worked better? Metering immediately, whole house surge protector, the 80-gallon heat pump hot water tank, larger rainwater tank, 1,400 gallons in a drought doesn't do it. I would have doubled that up. The feed-in tariffs need to be fixed. You saw the numbers, but we don't actually get paid on that. They reduced that to 3.3 cents a kilowatt, and so I've been receiving a check for $50 to $100 a year. When in fact the value of that is somewhere in the neighborhood of $1,000 to $1,500. And then last, changing the status quo at scale. We're still amazed at the number of buildings that go up that we can look at them. You can look at them and that they're going to perform very poorly for the occupants and create a lifetime of very high utility bills. Next slide, please.
And Robert, we are at the 10:31, so just this is your last slide.
That's the last slide, Sean. So that's my presentation. I'm sorry we didn't have a little bit more time for questions, but if there's something burning, I'm happy to oblige, or please feel free to reach out to me at info@greenideahouse.com. I'm happy to, I'm proud and happy to be as part of this community, someone who is happy to help.
Well, there is a really good question here. Danny Tam is an expert over at the Energy Commission on domestic hot water heat pumps. He's helped me with a lot. His question was, how much less electric resistance did you use after the installation of the 80-gallon tank? Did you quantify what you were showing us?
Yeah, I haven't officially quantified it, but it was really significant because there are two 4,500 watt resistance heating elements in even the new tank that I bought. But because you can lock out you can put it in heat pump only mode, you can lock out those two resistance units. And as you saw from my bill, it did not allow for those two 4,500 watt resistance units to come on. And so the heat pump works at 500 watts at max. It ramps up to 500 watts. So it's running, a lot down there, but in relation to what a resistance unit does, it's minimal.
Well, it sounds like it's 1/10 approximately.
Exactly.
Like maybe it's 11% or something.
Yeah.
Well, that's a fantastic fix. And we both know that, yeah, those tanks don't get recommended to be used that way. But it is an option in apartment complexes as well as a cheap heating system on the coast here. Other people have used it. So it's brilliant. So thank you, Robert.